Jay, you finished that quiz? Okay. Bring it up here, buddy. Alright, so let's look at this first one. Thank you. What type of coordinate do I have here, guys? A polar, and I want to convert it to rectangular. If I'm going to rectangular, I need an x and a what? So x equals r what? And y equals r sine of theta. So x equals 4 cosine 2 pi over 3. What is cosine of 2 pi over 3? What quadrant is 2 pi over 3 in? 2. So my cosine be positive or negative? So x equals negative 2. So y equals 2 square root of 3. So your ordered pair will be negative 2, 2 square root of 3. Are there any questions? Number 2, what format is that in? Rectangular, and I want what? So I need an r and a theta. R equals x squared plus square root of x squared plus y squared. How do I find my theta? What formula do I use? Tangent of theta equals y divided by x. I need a tangent that gives me a negative 1. What quadrants would that be in? 2 and 4. What family? So I got 3 pi over 4 and 7 pi over 4. I go back to this original. What quadrant is that in? 4. So I pick this one. So I got 2 square root of 2 and 7 pi over 4. That's my answer. Okay? Now, looking at equations. What type of equations is polar or rectangular? Polar. Polar, because you see an r and a theta. Do I want to work with secant? No, I'm going to rewrite that as r equals 5 cosine theta, and then I can just cross what? Okay, now, I want to go to rectangular, so I need to get rid of r cosine theta. What can I put in place of it? There's your answer. Okay, number 4, I want to get rid of r and theta. I want to go to rectangular. What am I missing on this side? I'm going to do r equals 2r sine. I'm going to multiply both sides by r, because I don't need to square that, do I? I just multiply both sides by r. Do you see that? Now, what can I replace with r squared? Equals 2y. Okay, what form is this in? Rectangular. X squared plus y squared can be substituted with what? Can I leave it r squared, or you got to get r by itself? When you take the square root of both sides, you got to put what? Plus or minus 3. What can I sub in for x? R cosine theta. Can you leave it like that? No, you have to get what by itself? And divide both sides by cosine theta. So r equals 4 secant theta. Are there any questions on this review? Let's look at these. I'm going to skip around. What type is this right here? R squared. Lamacent. That's like a bow tie, okay? Will I be on the 45 or horizontal? Okay. Take the square root of this out here in front. Square root of 1 is what? So I go here to one ring, and there's my graph. Here, what type is this? Lamacent is sine, so take the square root of 4, which is what? Go out to the second ring, and that's my graph. What type is this right here? Negative 2 cosine theta. That's a circle. Is everybody clear on that? Okay. Will it be horizontal or vertical? There's always a point at the what? Do I go right to or left to? There's your graph. What is this right here, guys? Rows. How do you notice a rows? The number in front of theta is greater than what? 1. Okay. Now, there's an understood 1, so I know my flower petal is going out to ring what? 1. Okay. How many petals will I have here, guys? 4, okay? So I'm going to say sine 2 theta equals 1 and sine 2 theta equals negative 1. What sine value gives you 1? What sine value gives you 1, class? Pi over 2. I'm going to divide everything by 2. I plug 0 in for n, I get pi over 4. Plug 1 in, I get 5 pi over 4. If I got 4 petals, 2 will come from this equation, 2 from this one. That would be 3 pi over 2. I get 3 pi over 4 and 7 pi over 4. So I'm going to go out to ring 1. And there's a point in the middle. There you go. Now this is plus or minus, so it's the top of what? Top of what in this one? Lambison. Will it be A is less than B? Absolute value. Will it be inner loop or dimple? Inner loop. Less loop. Yes. So you will make a what? Table. Plug 0 in. Cosine of 0 is 1. That gives me negative 1. Cosine of pi over 2 is 0. It gives me 1, 3, 1, and negative 1. Okay, let's make sure we know how to graph this. Go to 0. It's negative 1, so I'm going to go towards pi. Need to do a better job with my loop right there. Yes.
So if it ever goes through the pole, there's always a point there?
What now?
If the graph ever goes through the pole, there's always a point there?
Like on circles and roses and lambisons.
Okay.
Yep. Like on these, roses and circles, as always. Are there any questions on that? Are we good with our review? Okay, I want you to hand in your page, that first page, pass it to your center person. You have 30 seconds. Yeah, just put your name on both of them. I will staple them together later. Mm-hmm.
I've got my imaginary. It's on this paper. It's on this.
Okay, just staple it. Or not staple, just put your name on it if I look at it. You're just turning the first page unless both your homework is on both of them. I got to have it. So if it's both on there, then turn everything in. But I just need the first page, okay? All right. Quickly. All right. Does that mean, will you collect those for me, please? All right, let's look at our homework on the other page, page 610. It says, graph the complex number and find its modulus. Graph the complex number and find its modulus. All right. We're not going to do all these, but I will graph a few of them. When you're graphing complex numbers, thank you for that. We have something called the complex plane. This is the real axis. This is complex axis. This is 1, 2, 3, 4, and so forth, just like you learn. And then this is going to be I, 2I, 3I, 4I, 5I, negative I, negative 2I, negative 3I, negative 4I, and so forth. So on number 5, if I want 4I, now, I want to graph 4I. Think of this as, okay, normally you graph your x and your y axis, don't you, in the real world. Okay, in this, your A value, your real, corresponds to your x, and your b value corresponds to the y, okay? So I got 4i. So if I'm graphing 4i, guys, would I go anywhere or stay at 0 here?
0.
And then I will go up what? And I would label that 4i. What is your modulus for that one? What's the absolute value of 4i? 4. Did everybody get 4? And the formula for finding the absolute value, which is known as the modulus, is square root of a squared plus b squared. Okay, number 6, negative 3i. I start at my origin. I do not move. I go down 3. What is your modulus? What's your modulus for negative 3i? 3. Does everybody understand that? Number 7, negative 2. Is that a real or imaginary part? You start at your origin, go left 2. Do I move once I get there? No. What's your modulus for that? 2. Number 8. I start at my origin, go to 6. Do I need to go up or down? What's your modulus for that? 6. Number 9, 5 plus 2i. I want to graph 5 plus 2i. I'm going to go right 5 and up what? 2. That's 5 plus 2i. That's graphing that complex number. Now let's find the modulus of that. What is my a value? 5 squared plus 2 squared. That gives me 25 plus 4. My modulus would be square root of 29. Number 10, 7 minus 3i. I'll go right 7 and then down how many? And you get the square root of what? 58? Can you break that down? What, Taylor?
Do you only do the formula when you've got both parts?
Oh, no, I was just doing the formula in my head for 5 through 8. But you still do the formula, yes. Yeah. All right. So number 10 is square root of 58. Is everybody good with that? For the modulus. Number 11, square root of 3. Okay, what is the square root of 3? Get a decimal. 1 point what? Okay, so I go past 1. I go almost to 2, 1.7, and then up to I. I estimate. That's square root of 3 plus I. What's your modulus for that one? Come on, guys. You should have done this. What's the modulus? 2. You get 4. Square root of 4 is 2. Is everybody good with that? Okay. Number 12. Negative 1. Okay, what does square root of 3, negative square root of 3 over 3 give you? Some of us are just looking around the room. And guess what, guys? You can look around this room. That test will eat you alive come Thursday. I'm having a lot of patience right now, but you don't respond to me, I'm going to stop and you can just look in the book. You know what? Go on, Nick. Get your nose out. Okay. I wasn't talking to you. Polar form of complex numbers. That's our learning target. If you don't have these notes, that's in the yellow thing. So our first learning target. I can write complex numbers in polar form. Complex numbers in polar form. So here is the generic form for a complex number in polar form. Let Z be complex number equals an R times cosine theta plus I sine theta. I'm on the second page. Equals R times cosine theta plus I sine theta. Okay, so given this complex number, 1 plus I want to write it in this format. So I need an R and I need a theta in here. An R and a theta. How do I get an R from that? The R is equal to the modulus formula, square root of a squared plus b squared. So let's find the modulus of 1 plus I. That's 1 squared plus 1 squared. The modulus is square root of 2. So since that's the modulus, that is also my r. So I'm just going to let it be known that r equals that. Now I need my theta. You know theta was y divided by x, wasn't it? What have we been treating as like a y coordinate? Those start a y coordinate, A or B? B. It's going to be B divided by A. That's what that means right there. Tangent of theta equals B over A. So you get tangent of theta equals 1 over 1, which is equal to 1. What angles gives you a tangent of 1? 4 and what? 5 pi over 4. Now go back to the original. If I was to graph that in the traditional, that's 1 comma 1, wouldn't it? What quadrant would 1, 1 be in? So which one would you choose? Pi over 4. So now you have your two pieces of information. You're ready to write this. So your polar form for this complex number would be square root of 2 parentheses cosine of pi over 4 plus I sine pi over 4. And that is your answer. That is polar form for that complex number. So just think, guys, you got to be able to convert these regular coordinates, these regular equations, and know when to do this on test Thursday. So you can't go home and study for 20 minutes, I got it. And no one will come to my table and ask me if I'm doing it correctly. Okay? So you got to get all these formulas straight. You won't have these formulas either. Number 2, I'm going to find my modulus. Negative 1 squared plus square root of 3 squared. So my r is equal to 2. Tangent of theta equals b divided by a. I get square root of 3 over negative 1. Negative square root of 3. Which of the family members gives you a tangent of square root of 3? Pi over 3. You want a negative, so it's going to be in quad what? 2 and 4. Very good. So that's going to be 2 pi over 3 and 5 pi over 3. Now if you were to graph this in traditional, which quad would that be in, Zach? Negative 1 comma square root of 3.
Quadrant 2.
Yes, so 2 pi over 3 comes out of that, so I'm going to come up here and write 2 cosine 2 pi over 3 plus I sine 2 pi over 3. And that is your answer. You always put cosine first, sine second, I goes with sine. Are there any questions so far? Number 3. I'm going to find my modulus. I'm going to square negative 4 square root of 3. Negative 4 squared is 16. What happens to that square root in that square? So that's going to be what? 48 plus 16, which is 64. So my r is equal to 8. Square root of 64 is 8. Tangent of theta is b divided by 8. Negative 4 divided by negative 4 square root of 3. These negative 4's cancel out. I get 1 over square root of 3, which in turn goes to square root of 3 over 3 once I rationalize. Which family gives you a tangent of square root of 3 over 3? And it's positive, so I want the one out of quadrant 1 and quadrant what? So pi over 6 or 7 pi over 6. Go back to my original. What quadrant is that? If I was to graph this in traditional, what quadrant? 3. Very good. So which one do I choose? So this would be 8 cosine 7 pi over 6 plus I sine 7 pi over 6. I'm just going to ask you this. If you were to graph 6i with complex time, I will start here and go up what? Which gradient is up here? So would you have to work that out? That's pi over 2 right there. Do you see that? All right. Now we need to find the modulus. What's the modulus going to be? What's your A here? 0 and your B is? So your R is equal to what? So it would be 6 cosine pi over 2 plus I sine pi over 2. But you see why it's pi over 2? If it was 6i, if you were to graph this, A is 0, you stay put and go up 6i. And the same rating that's up here is pi over 2. Now let's think about negative 2 on the next one. What will be the modulus if you plug that in? Well, I say the modulus, the R value. 2 wouldn't. Because you have negative 2 squared plus 0 squared, which is 2. You could do some of this in your head. It's 2. Now let's think. Negative 2. If I was to graph it, where would it be? Pi. So you would use pi. Does that make sense? So you don't have to show me that if you know how to do that. So this would be 2 cosine pi plus I sine of pi. You can do things like that in your head, but like 1, 2, and 3 you have to work out. Does that make sense? Alright, so are we good on the first learning target? I can write complex numbers in polar form. Okay, next we're going to, I can multiply and divide complex numbers in polar form. So let's look at it. We have 2 examples. The last 2 for the day. It says to multiply 2 complex numbers, multiply the moduli. Oh, don't you like the word moduli? Moduli. And add the arguments. Just like you know, when multiplying like bases, you add the exponents. When dividing like bases, you do what? Subtract. That's the same concept. If you're multiplying, you multiply the moduli, which is right here, and then add your arguments. To divide, you divide these two and subtract. So look here, I want to say Z1 times Z2. You might see it written like that. Z1 times Z2. Okay, so you're going to multiply. You're going to multiply your moduli. 2 times 5 is 10. Those are your R values. 2 times 5 is 10. Put cosine now. Pi over 4 plus pi over 3 gives you what? 7 pi over 12. Yep. Plus I sine 7 pi over 12. That's your answer. Those are easy. You multiply your R values, your moduli, and add your arguments, your theta, your angles. Does that make sense? Okay, we did multiplication here. Let's do division on the next one. Z1 divided by Z2. Okay, I'm going to come to do... Oh, okay. Square root of 2 over 3 square root of 2. What happens to these square root of 2's? That makes it so you don't have to do no rationalizing denominator, do you? So you got 1/3. Now, what will you do with the 75 and 60? Will you divide or subtract? Subtract. You only multiply and divide the stuff on the outside, and you add and subtract. You only multiply and divide the stuff on the outside. You add and subtract inside. So 75 minus 60 is what? 15 plus I sine of 15. That's all. Does that make sense? Was that not too bad, was it? The hard part's tomorrow. This is still the easy part of the lesson. The next probably 2 days are hard. I did. I'm putting it all in there. Okay, because we've got some interesting coming up. Yes. No, what I did on the test was I put like, one of them says find, I have it like find Z1 times Z2 like that, and the other one I have Z1 over Z2 like that. You got to put one each on the test. So your homework now comes out of your book, and I did odd because you can check them in the back of the book. Did you know that all your odds in the back of the book? So please use that page 610, numbers 29 through 43 odd. That's the first part, and then 49 to 55 odd. Tomorrow we got two more. Oh, we got De Maurier's theorem tomorrow. De Maurier's. De Maurier's.
How do you say it?
I just say De Maurier's. I don't think that's correct, but that's going to include more days. You're French, aren't you? Did you have French class? So he's a French mathematician. Yeah. De Maurier's. All right. Okay, I need a handset on how you felt today. But you need to study, make sure, like, what I would do now, guys, is go through all this and make sure I know my formulas. If you need to write them down, everything so far. Have a good one. See you tomorrow. Projects due tomorrow. Projects due tomorrow.
Did I not get one of those sheets because I'm like not in? I did not get it.
Yeah, sorry. Never made a low video that way.
I better know where.
But let me ask you, right?
Okay.
Like just searching Have a good one. Have a good one, Laura. I am Smile. I'm Matt Griffin. I'm Miss Sherman. What you mad about?
I got these like bearings. They look like they're inside bearings. So I got them there for $4. And one of them fell out of the basement. Yeah, I figured. Can't put my phone
Morning. How you doing? Good. Good morning. Well, thank you. Good morning, Miss Fisher. Good morning.
Good morning, Mr. Hutchinson.
I don't know if you want this.
Hey, Mr.
Yeah. Can I sit this way? Oh. What do you have to experience? You want to pass? Scotty, missed you yesterday, Scotty. What? Yes. How's it going? I need you to review a quiz come in the morning.
Okay, wait, come in.
Good morning.
We got a test tomorrow. Man, I hate it.
Go get you a piece of candy for that one, Kathy. Hold on just a second, guys.